Hi, welcome to TechBus. In this video, I'll be showing you how you can make a switch mode power supply for your amplifier or any other project that requires a dual rail output. So the output voltage is plus or minus 55 volts and the current on the secondary side is up to 10 amperes. So it's based on the IR2153 half bridge driver IC and the IRF840 per MOSFETs. If you want more power, you can use the IRF460, the IRFP for 50 or the 20N60 for MOSFETs. So it's found directly from the mains, so you have the current limiting fuse of 6 amperes. So there's also a small filter made up of this X110 capacitor, this common mode choke and the other capacitor. So this acts to filter out the high frequency of from the switch mode power supply from affecting the mains. So there's also a resistor for limiting the inrush current when the input bulk capacitors are charging. So the mains is rectified by this full bridge rectifier, and then it's filtered by these two bulk capacitors connected in series. So you have your smooth DC. So they are connected from top to bottom. So there will be a split voltage at the node between the capacitors. There are also so these two resistors act as distance resistors to completely drain the capacitors when the power supply is plugged off the mains. So the IC gets its power directly from the high voltage DC through the 27 kilo ohms resistor, which should be rated at least 5 watts. So the input VCC pin is 1, and there's a stabilization capacitor 100 microfarads at least 25 volts. So the IC has an inbuilt 15 volts Zener diode. So the voltage at pin 1 will be 15 volts. So connect pin 1 to 8 together through this high frequency diode, the BA151. You can also use the FR107 or the UF4007. So also connect a bulk capacitor across pin 8 and 6 as shown. The value and voltage is as shown. So the frequency is determined by the resistor across pin 2 and 3 and the capacitor across pin 3 and 4. So with the parameters as shown, the frequency is about 50 kHz. So the timing resistor is 47 kilo ohms and the timing capacitor is 330 picofarads. So the outputs here, you have the raw sine driver pin and the high sine driver pin, as well as the common pin, pin 6. So when pin 7 is high, the upper MOSFET will conduct and current will flow from the high voltage DC rail through the MOSFET, through the primary winding, through the series capacitor, through the raw bulk capacitor into the negative rail. So when pin 5 is high, current will flow from the node between these two capacitors through the series capacitor, through the primary winding, through the raw MOSFET into the negative rail. So this is a half bridge configuration and it can achieve some really quite amount of power. It can handle more than 350 watts, which is rated for this case. It can output even up to 700 watts with the correct MOSFETs. Don't forget to mount the MOSFETs on appropriate sized heat sinks to display any excess heat generated. So when winding the power transformer, the core should be at least 1.5 cm squared. So initially make the first 20 turns of the primary winding, then make the secondary windings 10 plus 10 turns with the center tap. Then, and don't forget to add some insulation between the primary and secondary windings. Then make the last 20 turns for the primary winding. This will ensure that the secondary is sandwiched between the primary winding for more coupling. So on the secondary side, you have these rectifier diodes. So at the center, you have your 0 volts. So then you have your plus 35 volts and minus 35 volts. So these two inductors limit the inrush current drawn when changing these two output bulk capacitors. There is also a drain or a bleeder resistor on the output for discharging the capacitors when the power supply is not being used. So don't forget to drop a like, and I would appreciate very much if you subscribe to my channel and hit the notifications bell for updates about any future uploads. Have a nice time.